Okay, let's do another example. Here we have a box that's resting on a surface. There's a coefficient of friction of 0.30. We're going to pull up with a force of 40 newtons at an angle of 30 degrees. And the question is asking us to find the acceleration. So let's complete our free body diagram, always the first step. So we're going to have a normal force. We're going to have weight. And in this case, we're going to have friction. Anytime I see a force that's pointed up at an angle, I'm going to have to find the components of that force. So I'm going to draw in my components. Okay, this is F, P, X, and F, P, Y. Now that I have this, I'm going to write out Newton's second law, once for the horizontal and once for the vertical. So let's start off with the horizontal. The sum of the forces in the x direction equals mass times acceleration in the x direction. And looking at my free body diagram, I see two horizontal forces. I see Fpx and the force of friction. So I'm going to write those in. And defining the right to be positive, I'm going to come up with Fpx minus the force of friction equals mass times acceleration in the x direction. The net force in the y direction equals mass times acceleration in the y direction. Now this thing is going to be moving to the right. That means that the acceleration in the y direction is 0. And if I look at my free body diagram, I've got two up forces, the normal force, the y component of the pull force, and downward I have mg. So I'm going to fill in for some of the forces in the y direction, the normal force plus F P y minus mg equals 0. Okay, now we're going to eventually try to work our way over to solving for the acceleration in the x direction. So what I need to do is I'm going to have to start making some substitutions in here. Okay, so first of all, I know that Fpx is equal to F cosine of 30. I also know that the force of friction equals mu times the force normal. This equation here is going to become F times the cosine of 30 minus mu times the normal force equals mass times acceleration in the horizontal direction. As we so often do in these types of problems, we need to, the one thing that's going to hold us back over here is this normal force. So I'm going to solve the equation over here for the normal force and plug it in. So if I do that, I'm going to get that the normal force equals mg minus fpy. Now, I kind of forgot to do this over here, but fpy equals f sine of 30 degrees. The normal force equals mg minus f sine of 30. Okay, now I can substitute this normal force for the normal force over here, and let's see what we get. This becomes f cosine of 30 minus mu times everything that's on this side of the bottom equation, mg minus f sine of 30 equals the mass times the acceleration in the x direction. Okay, now we get to plug numbers in. And okay, what I'd like to do is I'm going to simplify this and get rid of the parentheses. So I'm going to say f cosine of 30 degrees minus mu mg. And the minus and a minus are going to be a plus, so plus mu f sine of 30 equals ma in the horizontal direction, divide both sides by mass, and we finally wind up with something we can put in our calculator to find this acceleration. And F again was 40 newtons. So I got 40 newtons times the cosine of 30 minus mu, which is 0.30, times m, 10 kilograms, times g, 9.8 meters per second squared plus mu 0.30 times F 40 newtons times the sine of 30, not sine, all over the mass of 10 kilograms. Ay caramba. And when the dust settles and we put that in our calculator, we get that our acceleration is 1.1 meters per second squared. It's a total coincidence that it happens to be the same answer as our last example. Lovely.